Today we will start with the interaction of the radiation with the matter. Interaction of radiation with matter, right? So before starting interaction of the radiation with the matter, we will discuss very important topic, that is attenuation, right? So what is attenuation? So basically it is a reduction in intensity of X-ray as it traverses the matter, as it traverses the matter. So very important, supposedly this is a matter, right? So the reduction may be caused either by absorption, either by the absorption, that is transfer all the energy to the matter. It transfer all the energy to the matter and is getting absorbed there only. Second is transmission. So this is the transmitted, right? So either it pass through unaffected or with the lower energy, right? So first is absorption, second is transmitted. Very important is the scattered, right? So it is diverted with or without energy loss. So third very important is scattered. Absorption, transmitted and scattered, right? Next is mechanism by which an X-ray photon interact with the matter, right? So we will study these two important topics. One is photon scattering and another is photon disappearance. So in photon scattering, we will discuss two important topics: coherent scattering and second is Compton effect. In photon disappearance, we will study photoelectric effect. Next is pair production and last is photo disintegration. Photo disintegration, right? Photon scattering, photon disappearance, coherent scattering, Compton effect, photoelectric effect, pair production, and photo disintegration, right? So first of all, we will start with the coherent scattering, right? So this is a nucleus, right? And outside the nucleus there are different shells, right? That is a K, L, next is M, N shell, right? So electrons are revolving, right? So before starting with the coherent scattering, I will tell you very important things, that is the potential energy and the binding energy, right? So amongst all this K, L, M, N, right? So K shell has the highest binding energy. K shell has the highest binding energy. So it takes more energy to remove an electron from K shell as compared to the L shell, right? So it requires more energy to eject this electron, right? So this is the binding energy. So K shell has the highest binding energy, and the lowest binding energy will be with the N shell, right? Next is potential energy. This N shell has the highest potential energy, means an electron of this N shell falling from the N shell to the K shell, अगर इलेक्ट्रॉन N शेल से K शेल में जा रहा है, it will release more energy as compared to अगर L से K में जा रहा है इलेक्ट्रॉन, तो it will release lesser energy as compared to the if the electron is falling from N shell to the K shell. So N shell has the highest potential energy and the K shell has the lowest potential energy, right? So K shell has the lowest potential energy, right? Now we will start with the coherent scattering. So that this is the incident photon, right? So this is the incident photon. This is the scattered photon. This is the scattered photon, but with the same energy. But with the same energy. So first of all, we will discuss this Compton scattering. इसके बहुत सारे नाम हैं. Also known as classical scattering, also known as unmodified scattering, also known as Thomson scattering, also known as Rayleigh scattering, right? कोहेरेंट स्कैटरिंग में फोटोन का सिर्फ डायरेक्शन बदल रहा है, बट देयर इज नो चेंज इन वेवलेंथ. देयर इज नो चेंज इन wavelength. There is only change in the direction. There is only change in the direction, right? It is also known as Thomson scattering if there is single electron involved in the interaction. Rayleigh if there is cooperative interaction of all electrons. So, what is the basic physics? जब ये एक्स-रे फोटोन इंसिडेंट फोटोन आएगा, it will cause the atom to excite. It will cause the atom to excite by exciting orbital electrons. ये फोटोन इन इलेक्ट्रॉन्स को क्या करेगा? एक्साइट करेगा. बट इस इंसिडेंट फोटोन के पास इतनी एनर्जी नहीं है कि यहां से ये इलेक्ट्रॉन कहीं बाहर निकल जाए। इस इंसिडेंट फोटोन के पास इतनी एनर्जी नहीं है कि ये इलेक्ट्रॉन यहां से बाहर निकल जाए। तो इसीलिए तो बोलते हैं कि जो कॉम्पटन स्कैटरिंग है, इट डज नॉट कॉज आयोनाइजेशन, इट डज नॉट कॉज आयोनाइजेशन, राइट, इट डज नॉट कॉज आयोनाइजेशन, राइट। सो जब ये इंसिडेंट फोटोन इस एटम को एक्साइट कर देगा तो एटम की एनर्जी क्या होगी, बढ़ जाएगी। तो वही जो एक्सेस एनर्जी एटम की बड़ी है, क्योंकि वो इंसिडेंट फोटोन ने एनर्जी पास ऑन की है इस एटम को, और ये जो एटम है ये जब एक्सेस ऑफ द एनर्जी को रिलीज करेगा ना, वो स्कैटर्ड फोटोन है। जो एक्सेस एनर्जी एटम को मिली है दैट विल बी रिलीज्ड एज अ scattered photon, and this scattered photon, there is only change in the direction but there is no change in the wavelength, right? So it means the scattered photon is released by a small deflection angle, right? So it represents the Compton scattering. It represents in only less than 5% of the X-ray interactions, and it occurs in low energy radiations, that is around 10 to 30 kilo electron volt. It occurs in low energy radiation, right? There is no advantage in the diagnostic radiology. So this is all about the Compton scattering. Thank you.